Okay, today's January 25th, 2012, Chapter 4 test. We're going to jump ahead to question number 4. A sportswear store sells baseball caps with the local team's logo on them. Last year, the store sold 600 caps at $15 each. The store manager is planning to increase the price. A survey of consumers shows that for every $1 increase in price, there will be a drop of $30 or 30 sales per year. What should the selling price be in order to maximize profits? What should the max revenue be in order to maximize profits? Well, think of the question like this. Their total revenue. Last year, their revenue consisted of number of shirts at $15 equaled a certain amount, which ended up being 600. Sorry, they sold 600 shirts, correct? So they sold 600 shirts at $15 each. Let's just bring the calculator up here. 15 times 600. $9,000 they made in revenue, okay? So this is just a reference point. What was important here is I wanted you guys to recognize that revenue is equal to price times what? Kind of wrote those. I wrote those backwards underneath which I want to write. 15 is our price, correct? So that's price. Revenue is equal to the price of the product multiplied by what? Sales. How much they sell. 600 is what they sold last year. Okay? So, what we're going to do is remember what's going to happen for every increase. We're going to think of this as a ratio. Okay? So let X be the ratio of shirts. X equal ratio of, sorry, it's not shirts, but price increases, okay? Price increase. So what happens is for every dollar increase, so for 15 plus X, okay? There will be a 30, so it's $1 times X. There will be a 30 sale drop. So that's the $600 or 600 sales from last year minus every price increase, which is 30 times that. So I should have put the one a little nicer in front of this. We're going to talk this through. This is like a ratio. So every time there is an increase in price, so say we increase it by $1. We replace X with 1. 1 times 1 is 1. 15 plus 1 is 16, which makes sense. A $1 increase would mean it would be $16. With that same increase, 1 times 30 is 30. We subtract 600. They now only sell 570 shirts or caps. What is it? Caps. Okay? Say they're to do a $2 increase. We replace X with 2. 2 times 1 is 2. 2 plus 15 is 17. We also replace that 2 here. 2 times 30 is 60. 600 minus 60 gives us 540. So again, the price is increasing, but their sales are decreasing in this question. So our revenue here, what we're going to do now is going to move to another page because this is going to take a bit and I don't quite have all the space because of how large I'm writing here. So when you first got this test, again, you were supposed to just continue increases in price and decreases in sales till you would have got a max revenue, okay? Now, I realized we're going to find an answer I'm going to tell you, and it's actually going to be a decimal. I realized you guys would have actually increased by dollar amounts. So if you had gotten to either sides on the far end or the near end of the actual amount, 50 cents off, I would have given it okay. It'll make sense once we start explaining it. So we are going to take this amount, 15 times 1x, or sorry, 15 plus 1x. We're going to put it on the next page. So revenue is equal to 15 plus 1 times x. So we're just going to leave it as x. Multiplied by 600, subtract 30x. Because they lose 30 sales for every increase in price. Now, They want us to find a max profit. Okay? What I'm going to do here is just to give you an idea of what kind of function we're dealing with. If you can't see it right now, what I'm going to do is I'm going to FOIL. Okay? So we're going to do the first terms by each other. 600 by 15, that's going to give us 9,000. 15 times 30, negative 30 is going to give us negative 450x. Okay? X times 600 plus 600x. And minus 30x squared. I'm going to rearrange this equation and collect my two like terms in the middle. Negative 30x squared plus 150x plus 9,000. What type of function are we dealing with right now? Yeah, 9,000. Anyone know what type of function this is?
Almost.
No?
You could have got it, sir.
This is a quadratic function. How do we know? Because we have a variable that is squared. It's in standard form right now. Technically, we were in factored form if you didn't notice that, okay? I wanted to put it in standard form just so you guys could see this. Now, it said they wanted to maximize profits. If we have a quadratic, what type of shape is that on a graph? It's a parabola, okay? Is this going to be a parabola opening upwards or downwards? Downwards because our a value is negative. So say we have something like this. What's the maximum going to be? What point of the parabola will that be called? The vertex. So essentially they're asking us to find the vertex of this function. What do I use to change standard into vertex form? So what we're going to be using is completing the square. Now, I want you to realize from the factored form, you could have found your two x-intercepts, divided them to find the axis of symmetry, and then found the vertex that way. This way, we're going to do it by completing the square. Okay? So, let's think about this. The revenue is going to equal negative 30x squared plus 150x plus 9,000. Now, remember, we take the first two terms and we divide them both by the coefficient of x squared. So the coefficient in front of x squared is negative 30. So we divide the first two terms by the coefficient in front of x. The negative 30 comes to the outside, so we're left with x squared minus 5x plus 9,000. Now, remember this negative 5x is now our new b term, and we do a little bit of side calculation here. We have that formula, b divided by 2 squared. Okay? We take negative 5 divided by 2. Negative 5 divided by 2 is going to be negative 2.5. And if you square it, what do we get? 6.25? Oh, that's nice. Okay, whoops. So, we're going to add and subtract 6.25 into those brackets. Because remember, we're trying to get a perfect square trinomial. So, oh, it's because I wrote this wrong. It should be 2.5, correct? Yes, I saw it. Okay. We take the negative 30, x squared minus 5x plus 6.25 minus 6.25 plus 9,000 on the outside. Now we need to move the negative number to the outside of this equation. And in order to do that, we have to multiply by the number that's in front of this equation. Okay? So when we do that, our next line will read negative 30 x squared minus 5x plus 6.25 plus, anyone help me out with that? 187.5 plus 9,000. Okay, so we're going to combine the terms on the outside of the brackets. Negative 30 x squared minus 5x plus 6.25. We're going to add 9,000 plus 187.5, which is 9,187.5. Works out very nice. Now remember, the reason we've done this is because we're trying to factor the bracket now. We've made it a special number to be factored. Okay. What we're going to do is we're going to find the square root of the first and last term here. So the first term is x squared. What is the square root of x squared? X. Square root of 6.25? 2.5, the number we used beforehand. So what happens now is this becomes one bracket with only two terms in it. We have our x. We have our, whoops, wrong number, 2.5. Now, what operation goes in between these two numbers?
Negative.
Yes, because the 5 is a negative, we bring down the negative sign. Okay? Then we end the bracket, and what has to go to the outside of these brackets? Squared. You must put squared there. The whole reason for this is because if you were actually go through the factoring of this, you would end up with this bracket twice. And we'll talk about it at the end, okay, just to make sense of it. So plus 9,187.5. So this is a transformation. We're in vertex form. So let's think about this, okay? What this is telling us is because our, you know what, we'll draw the equation like this. X squared plus, remember we have an A, an H, and a K. Now our A deals with, if we were to graph something like this, we know it's going to be flipped, stretched by a factor of 30. What is our H in this question? Our 2.5. Okay, the H is moving the vertex left and right. Which direction are we moving the vertex?
Right.
Positive. We're moving in the positive direction, 2.5. So I'm gonna make a sketch, not a graph. Sketches means it's just gonna be a rough estimate of the parabola. So let's say it goes over to here, which is 2.5 to the right. And what is our K value? 9,187.5. So what this means is the vertex of this parabola, it's going to come down. We don't exactly know where the x-intercepts are. But the coordinates of the vertex are x is 2.5, y is 9,187.5. So remember, what was this equal to? I know I haven't written the letter in a while, but what did we say R was? Revenue. So our y on this graph is revenue. So what is the max amount of revenue this company can earn? $9,187.50. And now what did X stand for? It's a little trick here.
You're not going to catch that. No. The amount that they're increasing it by.
The amount they increased the price by. So their price isn't 2.5. This is the amount they increase price by. Okay? So they're increasing it in dollars. They're increasing it by 2.5. So what is the new price to maximize? What was the old price? The old price was 15. We add 2.5 to maximize profit. This company needs to sell their caps at $17.50. If they do that, they will get $9,187.5. Now, so that's our answer here. New price, $17.50. Revenue was $9,187.5. Now, in your question, I know you guys would have possibly done trial and error. Say I given you these questions, right? When you look back and you're like, well, I didn't get that answer. I got 17 or I got 18. Is because logically you would only increase by increments of 1. All right? If you guys were actually do increments of like 0.1, it would have taken you a very long time to do this question. So logically, what you guys probably would have found is some of you would have had a price of either $17 or a price of $18. I think your revenue would have been, well, that's it, exactly. For either of those prices, you would have had the same revenue, okay? I accepted that because we hadn't actually learned how to complete the square yet. So those answers were right. But now that we do know how to complete the square, I would expect you to get this answer here. The price of $17.50 and a revenue of $9,187.5. So you would earn an extra $7.50. You're rich. Okay, we're going to jump ahead to number 9 now. Number 9 says to evaluate. This was in exponents. We did a quick lesson or two on this. Now, okay, so like I was saying before, evaluate. Now you could have taken a calculator, I think, with this and solved it. But we're going to talk about how to do that without a calculator. 4 to the power of 0 is 1. Okay? The next part says 2 to the power of negative 3. How do I make that a positive exponent? I flip it. Okay, so like we were saying, we flip it, we invert this to make this a positive exponent. And finally says plus 2 to the power of 2, is it? What is 2 to the power of 2? 4. Okay? So now, let's evaluate this fraction. What's 2 to the power of 3? 8. So it's 1 over 8 plus 4. So I have 1 plus 1 over 8 plus 4. What's 1 plus 4? 5 plus 1 over 8. 5 and 1/8. Or you could have put it as 41 over 8. But that's it. That's all I wanted you to do. Much easier than trying to figure out through a calculator. And in fact, if you put it through a calculator, I kind of knew because you put it into decimal form. And I know you guys did not evaluate that fraction into a decimal. I wanted you to figure this out using just your knowledge. So, the second part here. Negative 2 over 3 to the power of negative 3. Because this is a negative exponent, remember we said we flip the fraction. So what will this fraction now become if we're going to make it a positive exponent? 3 over 2, still negative, to the power of 3. Now this is to the power of 3 when we're evaluating exponents. Anything to the power of 3 just means you're multiplying the base times itself 3 times. Okay? So what is negative 3 times negative 3? 9. And 9 times negative 3? Negative 27. And 2 times 2?
4.
Times 2 again is 8. And that's it. Negative 27 or 8. Again, if you had given me some decimal, I knew you had typed it in the calculator and actually not have evaluated this. The path of a baseball after a batter hit a pop-up can be modeled by this equation. Important, so we highlight it. Where h represents height of the ball in meters, and horizontal distance is d. Okay, so our d is distance of the ball from home plate where it was hit. What's the maximum height? Right away, just by looking at this, we can figure out what the maximum height is. What would it be? 8. We're in vertex form, so the k value would be the maximum height. Height is in meters, so the max height is 8 meters. I think meters is spelled ER, isn't it?
Nope.
Oh. Okay. What? Oh, what was the height of the ball when it was hit? Yes, it is 8. What was the height of the ball when it was hit? Okay. So in order to figure that out, how far was the ball when it hit from home plate? Say this again. So, you're batting.
Oh, so cute.
A huge bat. The ball comes. You're on home plate. What is the distance from home plate when the ball is hit? 0. It's hit at home plate. So that means D is equal to 0. Now you're all laughing about this. I really don't know how I'm going to make that look any better. This is not going to work. We're just going to... There you go. There's the bad. Okay. So we plug this into the formula now. H is equal to negative 0.07. Our D value is 0. So 0 minus 10 squared plus 8. Okay. H is equal to negative 0.07. Negative 10 squared, what is that going to give us? 100. Negative 0.07 times 100 plus 8. This becomes negative 7. We multiply it by 100 plus 8. What's the height of the ball? So the ball is 1 meter above the ground when it is hit. That really doesn't look right. Isn't it here? Sorry, not negative. My fault.
Stop, man.
Positive.
I have chalk for that.
Finally, C. You could use a chart, a trial and error method to solve this, but we're going to show you using the formula. If no one caught the ball, what horizontal distance would it be from home plate when it hits the ground? Okay. Think about this. We have two variables, H and D. What are we trying to solve for in this one? D. We're trying to find the distance from home plate when it hits the ground. So we're looking for D. What is the height at that point? 0. So let's plug that in for the H in our equation. We have 0 is equal to negative 0.07 D minus 10 squared plus 8. Now we're going to isolate for D. I move 8 to the other side. What do I get? Negative 8 equals negative 0.07 D minus 10 squared. Now, I still need to isolate for D, so I'm going to divide both sides by negative 0.07. Let's get our calculator out here. Try to solve this. Negative 8 divided by negative 0.7 gives us positive 114.28. So we get 114.28 is equal to D equal minus 10 squared. What do I need to get rid of next? Squared. How do I do that? Square root both sides. So we square root the 114.28. Bring up the calculator again. Square root that number. 10.69, let's say. 10.69 is equal to 10 minus 10. Okay? When I bring that 10 over, what do we get? So 10 plus 10.69 equals D. A horizontal distance is 20, and we'll round it because we said to the nearest tenth of a meter, 0.7. So it is 20.7 meters away from home plate when it finally hits the ground, this ball.